Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about the units of Physics 1 and how they relate to each other and how we can use those units to make bigger units. And I'm going to be basically going over all the units real quickly in this video. I'll also do a separate video on the units of Physics 2, so if you want to check that out, I'll probably put the video link in the description below. But here's what we're going to say. Starting off with the most fundamental units would be distance, time, and mass. Distance, of course, is measured in meters, which is symbol m. Time is measured in seconds, that's the SI unit, and the symbol is just S. And finally, mass is measured in kilograms, and that will be using the symbol kg. There are many units in this class that just use these three quantities. So for instance, when we run into velocity or speed, that has units of meters per second, or meters divided by second. Acceleration, another extremely important concept in physics, has the units meters per second squared. And by the way, it doesn't have to be meters per second. For instance, velocity could be miles per hour. Acceleration could be feet per minute squared or something crazy like that. But the units I'm showing you are the SI units. In other words, these are the units that we're most likely going to see in physics class, and they're the preferred units whenever we have the option of choosing them. Another extremely common unit is the one for force. The units for force are the kilogram times meter per second squared. Looks like this. Now, kilogram meter per second squared takes a long time to say and to write, so instead we came up with the new unit, the Newton, which is capital N. Then we have another quantity, energy. Energy will have the units kilogram meter squared per second squared, which of course that's really long. So it's for that reason that we call the kilogram meter squared per second squared, we just call that J, which stands for joules, Joules. By the way, the units for energy are the same units for work, and that's because work and energy often go hand in hand with each other all the time in physics. And then here's another unit for you, the units for momentum. The units for momentum are the kilogram meter per second. Now, just like how we had a nice word for force, kilogram meter per second squared is called the Newton, you'd think that we have nice units for momentum, kilogram meter per second. But the truth is, we don't have nice units. This is all we've got. Which is why I tell all my students, as a joke, that you can also use the Wiesner as your units of momentum, which of course is my last name. And the symbol for the Wiesner is the capital cursive W. So you can use that whenever you're doing momentum problems in physics, and you will not get any credit in your physics class. But it is my life mission to make this the accepted units for momentum, so we're going to see if that takes off or not. Another fun fact for you, other units for momentum, and impulse by the way, because momentum and impulse are related to each other, the other unit you can use is the newtons times seconds, which looks like a very weird unit. It is not newtons divided by seconds, it is newtons times seconds. Yes, it looks very weird, but that's what we have to deal with. Then after we get through momentum, usually you're going to go through torque in physics. Now torque has the units newtons times meters. Now the funny thing about these units is that the newton times meters is actually technically the same thing as a joule, capital J, for energy and work. However, do not ever write capital J as your units for torque. They will not accept it. It is wrong. The reason why is because torque is a vector, which if you forget, that means it has both magnitude and direction, while energy and work are scalars. And remember, scalars just have magnitude, size, but they don't have direction. So for that reason, we cannot say joules, we have to write newtons times meters, and that's the only option you have for torque. After torque, we get into the other radial units. For instance, we have angular velocity and angular acceleration. These quantities have the units the radian per second for angular velocity and radians per second squared for angular acceleration. Now you may not know what a radian is, But the good news is you don't even need to know what that means. In case you're curious, I will give you the conversion. We say that 2 pi radians is equal to 1 rotation or revolution or oscillation. In other words, it's based on the circumference of a circle equation, which is 2 pi r. But that's not even important. All you need to know is that angular velocity is radians per second, angular acceleration is radians per second squared. And then the last unit I want to talk about is moment of inertia, because this is one of the weirder units in the class. Remember that the equation for moment of inertia is a mass times a distance r squared. And usually there's some constant in front, which I'll just write k, lowercase k, to represent my constant, where k can basically be any number. It depends on what shape we have. Like, for instance, when k is 1 mr squared, that's the moment of inertia for a hoop or a point source of mass. 1/2 mr squared is the moment of inertia for a solid disk. But I'm not here to talk about the equation. I'm just here to talk about the units. And the units are the kilogram times meters squared. Another one of our favorite units in this class. Very strange. And actually, just one more thing I want to mention. I forgot this one. There's a lot of coefficients in physics, whether we're talking about the coefficient of friction or the coefficient of restitution or any other number of coefficients you've heard of in this class. But whenever you see the word coefficient in the name, the units for coefficient of friction and all the other ones, well, the answer is that there are no units. They are unitless. So for instance, if I say the coefficient of friction is 0.3, then that's it. You would not have any units on that. It's just 0.3. And so yeah, that's basically all the units you have to worry about in Physics 1. If you have any questions or if you think I missed one, please reply in the comments section below. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.